Yeah, as Jiaxing has mentioned, today I'm gonna talk about Ko, a zero config deployment tools for Go applications. So we can make builds and deploys great again for our application developers. So before I begin, here's just a bit about myself. I'm Stanley, currently an engineer at Sendit, building payment infrastructure for Southeast Asia. I'm also one of the co-organizers for Go Singapore Meetup. So yeah, if you haven't joined yet, we are welcoming you. So I dabble in Go, Node, and deliver my apps to production with Docker and Kubernetes. So what exactly is Ko? Ko is a tool for building and deploying Go applications to Kubernetes. Ko is built around the Go import path dependencies, which I will explain in a later sections of the talk. But before that, let's take a deep dive into the problem that Ko is made for. So I'm assuming that most of us in the audience are familiar with containerization and Docker, but for those who don't know what containerization is, it's basically the technique of bundling all application components with its dependencies, configurations, and runtime environment as a self-contained module to be run in a host machine. So this is a basic process for Dockerizing a Go application and deploy it into a Kubernetes clusters, which involves compiling the binary, building the Docker image, publishing the image to Docker Hub or whichever repository you are using, and finally applying the deployment to your Kubernetes clusters. Fast forward to the age of microservices. Now we have to manage tons of different builds, each one of which has their own sets of Docker files. Things starts to grow out of control with lots and lots of configurations in form of Docker files and YAML files. So now some of you might be thinking about tools like Scaffold that can wrap this whole entire process for different languages and Docker files to make this process more manageable and faster. However, as application developers, we actually still need to write a lot of Docker files and typically even more YAML files to describe all of these orchestration. So these two actually only help us to automate the process, but we still need to write a lot of configurations. So actually, there's a pattern here that we can optimize in our development effort. The major pain point is that Dockerization process is too invasive in my development environment, requiring a lot of efforts for configuration. I'm not saying that this is not necessary, as at times we would still need to carefully handcraft our deployments based on the technology or business requirements. But at most of the other times, we actually have the same build configuration for majority of our applications or services. So Ko is targeting to solve this problem by providing a way to eliminate the needs for build and deploy configurations to eventually make containers invisible infrastructure. And one less thing for application developers to worry about. So this is the new model of our deployment process that Ko is constructing. Instead of having multiple Docker files, building images from each one of them, and pulling from the published repo to deploy to our Kubernetes clusters, we actually just need a one-liner that will handle everything to get our microservices up and running in the clusters. This is particularly useful for Knative developers as there's a need to manage a very large numbers of containerized images. And as a matter of fact, Ko was originally made for Knative developers and live inside one of Knative's repositories before it got extracted out into a separate repos and as a standalone tool. So how does Ko achieve that zero config deployment workflow? It leans into the Go idiom to simplify the whole process and eliminate custom configurations. In the same way that your local machine is using import path, Ko use Go import path to refer to the Go command that starts containers. So our concerns are now simplified from Docker build plus Docker publish plus Kubernetes into just Ko. So what are the features that Ko has to support this entire process? So first we have Ko publish. which simply builds and publishes images for each import path that was passed as an argument. The main function of the program must be in the path for code to build and publish a Docker container. So co-publish also support relative import paths and when in the context of a repo on Go path. So where does co-publish images to? By default, co will try to publish to your local Docker repo, but we can easily reconfigure that with this environment variable called co-docker repo. Next up, we have co-resolve, which will take the Kubernetes YAML file written in the written in the co convention in the same way as k-apply and determines which Go path to build, dockerize, and publish. The output of co-resolve is a concatenated YAML that with import paths replaced with the publish image digest. And finally, we have co-apply, which is parallel to kube control apply actually. Is acting on it acts on the output from co-resolve. And as developer make changes to the Go application, co-apply could actually be very useful to rapidly rebuild, repush, and redeploy your applications. And in addition to that, we also have co-delete, which is just a convenient wrapper for kube control delete to clean up resources created through co-apply. While code aims to have zero config, there are times where developers would want to override certain default behaviors. You can achieve this through ko.yaml file. This file can be included directly in the folder where ko is invoked. So what are some of the options that ko.yaml offer? So the first option available is default base image, which can be useful if we want to switch out the distroless default base image with some other specific image that fits our requirements better. And we can even do this for every single binaries that our co-cluster use by specifying the path with which the base image we want to use. Now, some of you might be asking as well, how do we include static assets for our applications to be deployed by co? So co data path environment variable is the answer. All content inside this path will be copied to the image and made available inside the images under the same environment variable. So co-data path actually defaults to co-data if not specified. This is drawn from an idiom another idiom in Go test where test data will be included and made available for Go test. All right, enough talking. So I'm gonna show you co in action. So in here, I have my standard Go application. So, okay, Go cluster to be specific. So I have like five different application which basically just serve a static image with some text. Yeah, and then I also have my custom Docker file written here, which build the app and then package it in the final image with the data from co-data. I'm using co-data folder here because it's easier to draw comparison when we are doing the exact same thing as co. So yes, for all of these five applications in my cluster, I'm actually having the exact same Docker file, which from my own experience, is always the case for most organizations because we actually have templates in how we want to build things, and we don't want to stray too far from that unless it's necessary. So yeah, so this is how I'm gonna build my application and deploy them without code with the standard Docker process. So here I have started my a global Kubernetes cluster using Minikube. So yeah, started. Takes some time to start it, so I started before the presentation. But yeah, the cluster is up. So now what I'm gonna need to do is to go in to build each of these applications. So I'm gonna Docker build, tag them with the right name. Oops. And yeah, I'm gonna have to build build an image first. Oh, yeah, my Docker is running. Thankfully, we didn't have to wait for Docker to boot up. So yeah, I'm gonna have to build my image, wait for it to build. Taking some time. All right, so I'm just gonna show you my Docker Hub as well to see that the images are pushed. So there's no images from the local Hello Universe application that because I just put my local Docker images, so downloading and extracting. Justin, I think if there are questions, we can start addressing immediately while we're waiting for this. So yeah, this is the kind of pain that we have to go through every day as developers.
Okay.
That's why we take so many coffee breaks.
Nice. All right, we can go through a couple of registration questions first while we are waiting for it to load.
Actually, it's just completed. So now I'm gonna push my image to Docker Hub.
This is the stress of coding life.
Oh, sorry. Miss out my surname. Yeah, so it's pushing now. And it doesn't just end here because I have another 4 applications that I have to get to Docker Hub before I can finally launch my clusters. So yeah, but the subsequent build will be faster because now I have all the base images, all the base Golang image in my local. So yeah, to make sure that I don't have to retype all this, I created a make file that I'm gonna run now to build everything and push to Docker Hub. Yeah, so yeah, in the meantime, I'm just gonna address some of the questions. Okay. So yeah, what's the first questions?
Yep. Are there any similar tooling to code in other programming languages?
So actually right now we only have Ko for Go. Ko is like Kubernetes plus Go, right? So I hope that we have
I did not realize that.
Yeah.
Nice.
We like puns.
Yeah, you can share the Kopi pun.
But yeah, it's actually not that hard to build a tools like this. But the main idea is that we want to have a base conventions that most of the time we don't stray from, and then the tools we just assume that we are following that conventions. So that's the idea of Ko. So instead of like offering a lot of configuration, we choose convention over everything else, and I would say that it works 95% of the time. Yep.
Okay. How do you foresee enterprise companies in adopting the tool, seeing that there's a large emphasis to split the deploying of applications away from CI processes?
Yeah, so it's actually not just for enterprise company, but as we see technologies mature, right, and like the complexity get higher and higher for like all of these very commoditized stuff, I would say. So like infrastructure nowadays is pretty commoditized. You don't want to do it yourself. You want to get someone else to manage it for you. So I think this is something that doesn't directly deliver business value, but we still need to get it done. So I think it would be very benefit for companies to adopt. I think it's not just benefit for them to adopt, but like they would definitely adopt convention over configuration. We do that in Stanley. Like we build a lot of our internal convention. We build a lot of our templates that every time someone wants to build a new application, they just make use of them instead of like trying to configure everything from the start. Oh, all right. Yeah, so just nice. All of the images just got pushed to Docker Hub. So
Okay, we are just gonna remove ourselves for now.
Yeah, thanks. you can stay if you want. All right. So yeah, I have all my images here, and then now I'm gonna deploy them to my local Kubernetes clusters. So like, yeah. Oh yeah. So these are the Kubernetes config that I'm using. So I'm using these images that I've just published, and yeah. So this is like the standard process without any automation that we are trying to get from code. So now that it's still creating my pods. See which one is ready. Okay, I don't like awkward silence, but yes, it's up. So yeah, so I have 5 of my services here. I'm gonna show you that it's actually running. You wanna travel to Earth? Actually, no, let's travel to Mars because we're on Earth. So right, yeah, the cluster is up and running. But let's try another service. All right, so that was a very arduous process, I would say. Arduous at best. And now I'm gonna delete my current clusters and show you how everything that I've just done could be achieved with ko in just a single command. So now everything has been removed. If I try to go back to the host just now, oh, why is it still running? It's not reachable anymore, so the cluster is down. So with ko, instead of like having having a Docker file for each of the application, now I'm just gonna have this ko import path inside my ko style Kubernetes YAML. So that with that in place, I'm just gonna do ko docker repo, my Docker Hub repo, and ko apply. So ko will take care of everything else for me. Now I can go for a coffee break. But actually, it's gonna be quite fast that I don't even need to go for a coffee break as usual. Yeah, so ko actually use the default base image is this shoulders one. So yeah, you can see here, it's using this base image to build each of my application, and then it built the Go binary. Oh, and I actually don't even need Docker to build with ko. So yeah, I just turn off my Docker daemons, and yeah, there's no problem. I can do it another time without Docker. And there's no problem. So ko actually doesn't use Docker to build images. It's actually directly compile the binary and compress it as another layer on top of the base image. So yeah, now ko actually have pushed all my images to Docker Hub. As you can see here, and it actually have applied all of them and created the exact same cluster as we as the one that we took 20 minutes. Sorry, it wasn't 20 minutes, but I think it was 10 minutes to create just now. So yeah, it's booting up. So ko did that with just a single command, and it was really fast because yeah, we are not downloading a lot of base images. We are not building each application individually, but like we build them concurrently in ko. So like now, if I'm trying to access my application service, I get the exact same result. And I actually only had to type one comment. Or I would say it's equivalent of like a single comment run on your CD environment, and no Docker required. No Docker required. Everything is inside code. Yep, so that's the power of code. Yeah, and that's all, folks. Thank you so much for tuning in. And if you have more questions, you can ping me on my Twitter, or you can find the code in this repo.